G'day and welcome back to Buildsum, and this is part 6 in the series of calculating wall bracing. And in this video I'm just going to look at the systems of bracing that are available to us and how much they can actually resist. So just to recap, basically what we've done, we've been through and we've worked out that from wind direction 1 we need 26.758 kilonewtons of resistance, and wind direction 2 we need 10.127 kilonewtons of resistance. Okay, so the timber framing code, table 8.18, lays out the different types of bracing we can use and the amount of resistance they will provide. Okay, so here we've got two diagonally opposed timber, all metal angle braces. Okay, it says they have to be between 1.8 to 2.7, so we get the right angle, less than more than 30 and less than 60 basically degrees. So they provide us with a resistance or a bracing capacity of 0.8 kilonewtons per meter. So if we went with a maximum length here, 2.7 times 0.8 gives us 2.16 kilonewtons of resistance for that type of bracing. And they do that for all the bracing. So here's a tensioned metal strap or a tension brace without any stud ties. It gives us 1.5 kilonewtons of resistance. So if it was 2.7 meters long, it would give us 4.05 kilonewtons of resistance for that unit. For a metal angle brace with stud ties, again 1.5, so again 4.05 kilonewtons of resistance. If you went to a tensioned brace with stud straps, okay, it doubles the capacity, so it gives you a bracing capacity of 3 meters. So if you went 2.7 long, you get 8.01 kilonewtons of resistance out of that bracing setup. You also have your plywood. So a ply sheet gives you 3.4 kilonewtons of resistance per meter. So your average sheet's 1.2. So 1.2 times 3.4 gives you 4.8 kilonewtons of resistance per plywood sheet. Alright, that's just standard nailing. And then depending on how you fix it, okay, you can use different methods. Method A and method B just talks about how it's actually fixed to the floor and the amount of nails that you put around the sheet. Okay, you can look them up in the code itself. So method A, 6.4 kilonewtons per meter by 1.2, that would give you a resistance of 7.68 kilonewtons. Which sounds really good, but there's a lot of work to actually get a method A installation. So you have to toss up whether you're going to go to that extra work or you're just going to put in extra sheets. Okay, and here's another one. So again, another plywood system, depending on the thickness of the ply this time. So if the ply was 4.5 millimeters thick, it'll give you a resistance of 7.5, and if it was 7 mil thick, it will give you a resistance of 8.7 per meter. So again, 1.2 times 8.7, you could possibly get a resistance of 10.44 kilonewtons out of that sheet. Okay, now that sounds really good. This means that we could probably get our wind direction 2 with one sheet. However, there are a few other factors that may make that uneconomical and just not worth the effort, because we're going to have to put extra sheets on anyway, which you'll see later on. Okay, so they're the different types of bracing systems, just a few of them. There are more in the timber framing code. Okay, but that just gives you an idea of the bracing capacity of some of those systems. And then in the next video, we're going to work out how many we actually need to resist the force in each of our directions. G'day, I'm back. Just to let you know that if you like this video, you can subscribe to my YouTube channel, or you can follow me on Facebook so you don't miss out on more great videos.